Today we'll see the missing value imputation, which is very helpful in our pre-processing kind of the constructs. And of course, it definitely give us a kind of betterment in the uh, corresponding accuracy also. Because you may be wondering, how come the accuracy will increase with respect to the specification of this missing value imputation, because generally the point here is missing values are something like which are basically available or basically into the data set. So we are having some sort of the data sets and all. 1 minute guys, one. So here, suppose if you are having any kind of the data, maybe if you know guys, just we are making use of the convention. Like suppose I'm having some kind of the data. Just it is asking. Okay. So the missing values. So just it is nothing but suppose I'm having some kind of the data with me, and maybe feature 1, feature 2, yeah, feature 3, and feature 4. So here maybe we are having some null somewhere. Like this. So now the problem here is if you consider the corresponding record. Okay, this is nothing but a row. It may be causing some disturbance to us, like only one feature we are having in the corresponding second row. And if you consider this particular column, we don't have any values. Okay, this is nothing but the missing value, because we may not get the proper specification of the values, and it is always important for us so as to deal these kind of the missing values without fail. Okay, now to handle this particular kind of the convention, we are having certain process and procedures, guys. If I am referencing the appropriate aspect, I have taken some example where this example is helping us so as to understand how we are making use of missing value imputation and all. There are certain here I scoped some 5 different categories of the missing values, and I thought of giving you this understanding with some example also. Okay, and of course there is some a little bit context before entering into the missing value imputation. So just I have taken some case study here, guys. Let me give the context of that. Okay, now have a look on this, guys. Just the process of data cleaning we are starting is the process of finding and correcting the inaccurate or incorrect data. Inaccuracy specifies that. So whatever the data we are working on, if that particular data is not giving us the proper input or proper correctness of the data, then it leads to the incorrect data or inaccurate data. Okay, like just now we have seen. So whatever the aspects we have considered, some of the rows are not even having the null values. Only one feature is having, and remaining and all. Okay, just they are presenting. That's all. Coming to the other thing, one such process needed is to do something about the values that are missing in the data set. Okay, this particular data set is containing some missing value, we need to handle that missing value. In real life, many data sets will have many missing values. So dealing with them is an important step. That's what I said. In the real time scenarios, data may not be coming in quality or such kind of aspects. It is just simply, it is coming in all the shapes. So it is as a data scientist, as a data engineer, we need to handle those kind of the convention. Most importantly, why do we need to fill in the missing data? So the reason is simple, because most of the machine learning models that you want to use will provide an error if you pass missing values into it. I will show you that. Suppose if I'm without performing any curation, just as it easily if I'm submitting my null values data set to the algorithm, and maybe a few algorithms are not giving us the outcome because they are unable to handle the null values. So this is how you can specify the usage. So now the conclusion here is, guys, missing value should be handled because first point is inaccurate or incorrect data. Next important thing is some of the algorithms are unable to perform the activities of this null values in the proper way. So these two are the reasons. Now the easiest way is to just fill them up with 0, but this can reduce our model accuracy significantly. Of course, rather than leaving them as null values, it is always better to fill with 0. But even we are not sure that this particular 0 is the suitable or correct replacement for that null. So there are certain aspects where you can think through how we are making use of the convention of imputing the missing value, handling the missing value. Okay. And for filling missing values, guys, as you know, I use it to insist on many aspects, especially in the data pre-processing. Okay, so this particular data pre-processing, now we are dealing with the missing value imputation. How to handle the nulls and all these kind of things. Our second important thing is after giving the missing value imputation, just we need to specify the feature engineering like encoding. Yesterday in the earlier session, we have seen some sort of the encoding technique, one hot encoding. Okay, dummy encoding like that we have seen, just to give the example. And then we are managing some sort of scaling actually. Okay, normalization. So as to mention, and I'll scope this particular aspect in the next session. So far we have done with the encoding, and now we are doing the missing value imputation. So these three aspects are 90% of your data pre-processing is handled by these three aspects, friends. Encoding, one-hot encoding, target encoding, dummy encoding, all these things we have seen. Label encoding also even. And if you refer the aspect of pre-processing related to the missing value imputation, just this is one of the important techniques so as to handle the data pre-processing in the efficient way. So for filling missing values, there are many methods. Obviously, 5 methods I'm going to discuss, and even some more methods would be there, guys. But at this moment, in the industry, we are using these 5 methodologies. For choosing the best method, you need to understand the type of missing value and its significance. This is the most important point, friend, because as how we cannot say this algorithm is suitable to this kind of the data set. It is also choosing the, as I said, 5 different methods are there in the missing value imputation. Choosing that particular thing is somewhat significant. Okay, so understand the type of missing value and its significance before you start filling or deleting the data to completely understand how to handle the missing values, because it's not like whenever you are seeing a as I said here a row, it is easy to delete that particular row. But what about this value? Maybe this value may give some kind of the insights to us. It may give some valuable information for us. So in that particular case, definitely we have to be very cautious and we should be very clear about what exactly we are trying to do. Okay, now you observe here. So significance and at the same time understanding of the data is most important. So now what we are doing is in this explanation, Titanic data set, actually this Kaggle is providing us some sort of data sets. So you can straight away go and download this particular Titanic data set. Now coming to the other thing, I want to show you some data set information, because as I said, guys, before attempting any kind of the things, first we should see what exactly the data is conveying to us. If you observe this particular thing, let me spend some time related to the corresponding data set. So passenger ID survived or not survived, survived in the sense after syncing up that particular whose liner is a fuse thing, and whether those guys are survived or not. And the class of the passenger and name, gender, age, sibling, all these informations are available, friends. Now we are making use of this information, and I have shown you some part of this data set. But we do have some null values. So before going to handle or impute the null values, first we need to see that how to verify whether nulls are present or not. First we should know, we should know how whether the null values are present or not. So for this particular purpose, just we're having some techniques, friends, before handling any kind of the aspect. Just we're having some technique. Uh, and moreover, here one more important thing is avoiding the unnecessary data items. Okay, name, ticket, passenger ID, cabin, embarked. These things may not be helpful to us, guys. Okay, because our interest is to verify and handle the missing value kind of thing. Now, what we are doing is we want to perform some sort of the analysis and avoiding the unnecessary data items. Okay, so this data frame, of course, friends, we have to import numpy as np, import pandas as pd. This is by default. No? So data frame, just we can load that particular data, and so that we are dropping these kind of things. And what I want to drop is name, the ticket, a passenger ID, cabin, some embarked. All these kind of the details are I don't want to use those kind of details. Just we are dropping those kind of thing. In place equal to true means, guys, just this kind of thing where in place equal to true refers to I want to permanent. Okay, I want to apply the changes to the data frame. And if I don't want to make the changes permanently, then I can leave that. If you are very specific to the in place kind of thing, if you want to maintain that convention of the in place, committing the corresponding whatever the information I'm having, whatever the updates I have done, I can make use of the in place equal to. Once that is over, so now what we are trying to do is some sort of the categorical data are there. So now I want to maintain some kind of label encoding, which is also known as the one-hot encoding. In the earlier session, we have seen that kind of the aspect. So just to have a look on this, guys, how we are making use of that label encoding. So SKLN pre-processing, just we can import the label encoder. Just we are creating a reference of that label encoder LE, and the gender fit and transform directly. What we are doing is this data frame we are copying to the new data frame. Okay, so as to maintain the originality of the data. Now, definitely I have to maintain the train set and this thing actually X and Y, where if you are referencing the Y who are all survived, and we need to drop that particular thing. And of course, just what we are doing is just we are making use of that survived as a drop. So just we are making use of this label encoding and all the splitting of the data into X and Y. Now the other thing is, guys, here up to this, okay, just what we are loading the data and we are performing some sort of the analysis, and we are eliminating some corresponding details. Okay, whatever the details we are not interested or required, we have deleted that. But in what way we are going to identify whether missing values are present in our data or not? Because our interest is this thing only at this moment. So for that, we're having this notion, guys. How do we how to know whether the data has missing values or not? Because once you load your data into the data frame, no matter whether in Python or in PySpark, in both the kind of things, the data frame is common. It's a tabular representation. And how do I handle this missing value kind of thing? So just missing values are usually represented in the form of the NaN, null or none in the data set. So at the moment you load the data into the data frame, either of these kind of thing, either none should be there, or else null might be there, or NaN, not a number kind of thing. That is how Python or PySpark are dealing with the null values or missing values. So missing value may not be always in a single genre, friends. Maybe it is none, null value, or not a number kind of thing. And df.info, just what it does is information, the function can be used to give the information about the data set. So this will provide you with the column names along with the number of non-null values in each column. Okay, na? So just why I'm having some approach df.info. If I'm giving, I can able to see the non-null values. Assume that I'm having 1,000 values, and out of these 1,000, if I'm saying 990 values are non-null, then obviously these 10 values are null. Like that, we can able to identify whether our data set is contain the null values or not. So going ahead, guys, just if I'm talking about our Titanic data set, just you can observe this way what exactly the values containing. So here, so all these kind of things, maybe I'm having 891 entries I'm having. Out of 891, this passenger class, gender are having all null nulls, but age only 714 are having the non-null. That means remaining values out of 891, only 714 we are getting the non-null values, and all other siblings, this parachute available fair. Okay, so parent child kind of thing, all these aspects you can see the like in the description you can observe, friends. Okay, so while preparing the appropriate estimations related to the data set, you can follow up that convention. Okay, describe the data which gives the information about all the things, but our requirement here is we need to see whether all the details, whether all these kind of information is containing the null values or non-null values. If you observe this age, especially explicitly, we can see there are null values in the column age. Okay, we are very sure that remaining columns are having the non-null values, but only this age column is having the null values. So now we got the conclusion, like how we can make use of the convention. And one more option is there, friends, which is generally other than the df.info, we are having the alternative method to see the null values. So have a look on this. So the kind of information we are getting is all the informations, how many non-nulls are there. But exclusively, if you want to get the summation of all the null values, what you can do is within the data frame, we are having a function called is null, and we are summating all those null values. Now you clearly observe here around 177 null values we are having in the age column. Remaining and all don't have any null values. That's what they are showing, all zeros. Okay, these entries are containing the zero values. But whereas at the moment I am talking about this particular age kind of thing, this is containing 177. So that is your wish, friends. Maybe as a data, I mean processing, either you can go with the info and as well as this way. Just by using the data frame, and you can apply on null and summate the same. See that all the null values in the data set are in the column age. Just you can observe this convention, all the null values. OK, now we are pretty clear that our age column is having the null values. Now what I need to do is one simple thing, guys, here. As I said earlier, some of the algorithms are not able to use, not able to entertain these null values, and they are oppose us. They are going to oppose us. Now let me show you that thing, whether really the algorithms are going to oppose, or is there any logic behind that. Now let us spend some time here. Just I want to implement the logistic. And of course, this is the classification technique, and which is at the end of the model, it should give either yes or no or true or false kind of thing, 1 or 0. All these kind of the uh, things can be belongs to the classification, like decision trees, random forest, and naive Bayes, support vector machine, k nearest neighborhood. All these things we have seen. Okay, these are all belongs to the classification techniques. And one of the such classification technique is the logistic regression. We are trying to give this input data, whatever we are having. Suppose I am having the data set, and the data set we have not handled the null values. Null values are there, and we have not taken any measure to handle that null values. And as it is, whatever I'm having in my hand, so the data set, just I am giving it to the model. Okay, just to scope this particular thing, what we are doing is from scikit-learn library, we are taking the model selection. Within that module, we're having the train test split. Just we are splitting the test size 30 means training size is 70%. 70-30 here we have taken. And of course, 4 dimensions would be generated, na? X train, X test, Y train, and Y test. Now what we are doing is just we are importing the linear model and we are importing the linear regression. We try to refer the LR with respect to the logistic regression, and we are trying to fit the model actually. You know, friends, fit and predict, two important things. Where fitting the model is nothing but launching your model, and this is the validation. Okay, whether that model is properly giving the outcome to test the accuracy and all, we can do that. So at the moment we are running this code, it has given this error, guys. Input contains NaN infinity or a value too large for data type. So we are pretty clear that our data set is having the null values, and they are referenced by NaN kind of thing. So likewise, we are uh, uh, observing that null value specification. So one thing is clear, null values are causing some trouble to the algorithm implementation. Now, what is the remedy? Remedy is nothing but the kind of solutions we're having so as to avoid this kind of the notion. We are having total in the beginning of the session, I said 5 different principles we are having, friends. See here. Okay, so let us try to observe these points. if you see the above implementation, the logistic regression model doesn't work as we have not a number value in the data set. Okay, not a number kind of thing. So simply it is not allowing us to perform the act. Only some of the machine learning algorithms can work with the missing values, and maybe sometimes they are asking this question. Even I'm having the missing values, then what is the best algorithm we can use? KNN can be used as a suitable classification technique if your data is containing the null values. But here our analogy is uh, but how it is handling that particular thing is which will ignore the values with NaN values. So just it is ignoring the values, guys, ignoring the missing value, whereas your logistic regression is not ignoring the values. It try to scope that particular values. Okay, so that is one of the important consideration we have to see. Though some algorithms are there which are ready to handle your missing value, but the point here is, guys, I'll show you that if you handle the missing value, we are getting some betterment in the accuracy. So keep that point in mind. So though some of the algorithms are supporting the handling of the missing values, but still we are not going that side. Reason is due to some prediction or accuracy loss, we are always preferring holding off these kind of things into the natural way. So that means we need to handle the missing values in a proper way so as to expect the betterment in the corresponding observation, betterment in the accuracy of the model. Now we are having a different thing, guys, like, deleting the columns with missing data. The entire column can be deleted. Okay, so whereas if you are referencing the other thing, deleting the rows with the missing data, whatever the rows I'm having, so I can able to delete that row. But these two things are bit extreme kind of things, guys, because without any hesitation, if I'm directly deleting the columns or rows, in that there is no technique actually, like directly we are deleting the rows or columns, which leads to some sort of um, though it is avoiding the missing values in our data, but in a way, if I'm deleting the row, it is giving some kind of impact on the accuracy also. So just to observe that point. And though, of course, we are not ignoring these two. Of course, we need to sometimes, if 30% of your data or 30% of that particular information is null, then with greater than 30, then we can take a chance with the discussion of the subject matter experts. Coming to the next aspect, this is the most commonly used technique of handling the missing value, finding the missing data with a value. That is what you call the missing value imputation actually. That, however, we are doing. And next thing is sometimes there is a possibility of adding one more column, imputation with an additional column. And next thing is finally either I can fill in with a regression model. Um, Here, friends, there is a chance of using some algorithms to handle the missing values because this is a quite advanced aspect. I mean, though the other four are more or less you might be having the idea like deletion of the column or deletion of the row and filling the missing data. And fourth one also we rarely use like addition of the column related to the corresponding missing value. And finally, we are having a filling with a regression model. Okay, whatever the idea we are having, that model we are trying to get. Okay, so let us see one by one. First thing is the missing data columns deletion and then row deletion. Okay, for that, just I am having this example. So the same kind of the data set we are making use and we are trying to understand the deletion process. Now deleting the column with the missing data. So just you are observing this column, actually A, B, A, and as well as A. And what we are doing is just we are whatever the column I am having. So just simply we are deleting that and we are end up our process with column 1 only, because we don't want to get into trouble with the usage of the second one. So in this case, let's delete the column age and then fit the model and check for accuracy. But as I said, is the extreme case and should only be used when there are many null values in the column. So your age, though it is containing 117, okay, out of some 891, maybe 20%. Okay, so not even 30%. So we are having 20% of the null values. But as per the principle, you can decide if I want to delete that particular information, then I can do that. So simple. There is a procedure. Okay, but only the tough thing is to make the decision of deleting the column, not the deletion actually. Okay, deletion is easy, but to come to that particular conclusion is definitely difficult. So what we are doing is updated data frame. Just I am drop and a drop nulls. Okay, so directly I'm pointing to the columns. Now if you give the df.info, okay, so just I am not having the age column. Directly I dropped that one, whichever the column is having the null values. Now I am getting only 4 columns. Earlier we are having the 5 columns. I mean 6 columns earlier, now 5 columns because this index start from 0 now 5. So likewise, I am making use of dropping the age and I can see all the other kind of the aspects. Now the point is what is the impact? Okay, after deletion of age, what is the impact of our implementation? Simple, one by one we'll see. As a result of the first dropping of the column, and with the help of this logistic regression, now you can easily observe that it is not causing any error. Earlier, with the age column, if I'm trying to give my data set to the logistic regression, it opposed us actually. Okay, like the value error, null values are there like that. Now, as you can clearly observe that as we have deleted that column age, now our logistic regression is not complaining anything. Just we are making use of some metrics, and we are even in today's Teams day-wise schedule also. I have posted this metrics, friends. Actually, the metrics of regression. Okay, and the metrics of the classification already we have seen. Classification to notify again, classification is having some sort of the confusion matrix. Okay, accuracy, precision, recall, like that we're having. Whereas if you are talking about the regression, R square, adjusted R square, root mean square error, root absolute error, okay, root mean square error, like that we're having some sort of the measures. All are important, guys. Definitely they're asking some questions. So we try to implement this model with a logistic regression, and we can able to see the accuracy score. Like, after fitting the model, after creation of your model, we need to check that the appropriate prediction. Okay, prediction the model, and we are printing the accuracy score. Around we got 79% of the accuracy. So that means without the age, of course, not bad. Nearby 80% of the accuracy we can see with compared with the original data. Our model could able to observe. So very simple aspect, observation of the null values, deleting the corresponding column. What is the second method, guys? Yes, second method is deletion of the rows. But before going to explain what exactly the second method, I want to give you some drawbacks. Suppose if I am deleting my column, what is the problem with that? See that we can achieve an accuracy of 79.4. The problem with this method is that we may lose some valuable information on that feature as we have deleted it completely due to some null values. Should only be used if there are too many null values. We have to notify this point, guys. Okay, we are not able to capture or scope that particular value, and we are making use of too many. If that particular feature is having the too many null values, then only we are going to take the decision. That is the most important point. So that's how we need to identify the things. Now the other point is the second way, the second principle. Just what we are doing is deleting the row with the missing values. Earlier we have taken the column so as to handle the missing value imputation. Now what we are doing is we are deleting the row with the missing data. If there is a certain row with the missing data, then you can delete the entire row with all the features in the row. That means this time we are not focusing on a single column, but the appropriate row which is containing the null values. Remember friends, one point, x is equal to 1 is used to drop the column. X is equal to 0 is used to drop the row. If any Python code is containing access 1, I can say that as a row column deletion. Whereas if you are interested to delete the row, then you can use the access equal to 0. Okay, we are clear on this. Earlier we have used the access 1. Now we are going to use the access 0. Now, but what is the process? How do I achieve that particular thing? Simple. In the earlier case, I have used the access 1 for the column. Now I can use the access 0. The same thing. Updated data frame, drop NA, access 0, and we are making use of the y value. And now updated df.info. Now there is a differentiation, guys. In the earlier thing, just we have dropped or we have deleted the age, which is containing the null values as a column we have deleted. But this time we deleted the rows which are having the null values. Now you see your number of rows also getting decreased. Now you in the earlier example, we are having around 891 entries. Now we are only having 714 entries. Reason is simple. Um, in the 714 all are non-null values only, because we were interested to drop the rows rather than the columns. The dropping of the rows, all these kind of the conventions. So this is the picture. Now we have not deleted the age, but age is also there along with that. Earlier we are having only 5 entries. Now we are having the 6 entries. Okay, more data definitely gives some more insights of the model into the model. We have to prove that. Let me show you how do we achieve that particular convention. Now as a part of this particular thing, we can able to scope that age also. Quite interesting results, guys. Similar, all these implementations, metrics, train test split, and taking the test size as 30%. And then we are importing linear model, logistic regression, implementation of that model, prediction, accuracy score. Earlier we got without age, we got something like 79.4 accuracy, where with age, okay, just we got some 82.3, which is definitely more. Okay, so you can realize now, like suppose it is easy to drop or delete the appropriate column, but definitely that deleted column may be adding some value to our accuracy, because always we need to stick on to minimum 80% at least accuracy. Maybe in medical domain, we have to cope up with the 90s also. So in this scenario, it's not good to drop the entire column. Reason already we have seen, logically we may lose some information, and but whereas, and one more thing, with that particular thing we may get some insights also. But now we can able to see that without age, we have registered 79.4% accuracy related to the data frame in that implementation of the data set with the logistic regression model. To create the model, we have used this logistic regression algorithm. This model recorded 79.4 without age, but with age implementation by including age also, just we can come up with 82.3%. Here itself, you can see that what is the damage if you delete the column entirely rather than the row. So pretty convincing. So obviously there is the conclusion, as I said. So just whatever the value I got, just if you refer this kind of convention, guys, in this case, that we are able to achieve better accuracy than before. And this is maybe because the column age contains more valuable information than we expected. Okay, around 4% accuracy increased actually. Okay, now the third thing, guys, actually third thing, what is that third one? Let me check. Okay, the third thing, filling the missing data with a value. This is the most commonly used approach. Maybe with the mean in the earlier sessions also we have discussed this point, but practically we'll see now. Filling the missing values with a mean or a median or according to the requirement. But generally, if you if you identify this example, I'm having column 1 and column 2. Just this NaN can be put up with the mean value. That means all the values, whatever I'm having. Mean is a pretty favorite formula now from our schooling days. Just to take all the values by number of values. As we consider 10, 19, and 12, just three values. So the average of those things 13.66. So we can put that particular value as a instead of that null. So if you are referencing this kind of thing, I have collected some data for us, guys. When can we use the mean value? When can we apply the kind of the convention? There is a situation actually where you can observe these points actually. Okay, like maybe we overlook some of the conceptual things, friends, which are very much important, especially to clear the certification. So in case we'll be filling the missing values with a certain number, and here also they have given to impute the missing values. There are certain hints they are giving. The first priority given to the missing data with mean, median value, the numerical variable. Numerical maybe salary or in age, those kind of the situations, you can go ahead with the missing value, mean or median. Second thing is filling the missing data with mode if it is categorical data. Categorical, sometimes, maybe country name and blood groups. Okay, there are certain categorical kind of the values. So just you can make use of this mode kind of the filling. Filling the numerical value with 0 or minus 999. This is also some filling of 0 or something like that. Some other number that will not occur in the data. This can be done so that the machine can recognize that the data is not real or it is different. Because 1, 10, 15 like that we're having. Rather, what you are doing is 0 or some value we are mentioning, which clearly indicates that this is not exactly the real value. Even we are explicitly mentioning that. And filling the categorical value with a new type of the missing values, you can use fill any function to fill the null values in the data set. Like that, you can fill any of mean, fill any of mode, median, something like that. Okay, we are good up to here. Now trying to exhibit this particular aspect. Pretty simple, guys. Directly what we are making is just we come to some conclusion. I want to apply the mean. So just we are making use of that particular mean. And whenever we are getting the null values, so those with the help of the fill NA, I'm filling this age with the mean. So now as a recheck, after updating this particular missing value imputation of the age, so then you can make use of this info. Now you can see all the values, no records, no columns we are deleting. Rather what we are doing, whenever I am seeing the null value, just I want to fill that and surprisingly here, not surprisingly, unfortunately or unfortunately, we are having only one column with null. Multiple columns may be there, guys. In that case, we have to handle them individually, as we have seen, like categorical how to handle or numerical how to handle. The convention you can follow. So here we are not attempted to delete the column, or we have not attempted to delete the row. But what we're doing is we want to impute the value, mean, median, or mode, or something like that. Now you see all your 891 data got filled, and we are having all these details. OK, we are not ignoring any data items. That is the underlying point we need to observe. Now, this time giving one more surprise to you. Because these example I have taken, maybe later I realized that I could have taken some other example, but it's okay, guys. It happens. So as to give you some different road, I selected intentionally this example. Now what we are doing is just we are taking that logistic regression implementation. Now all these things are common. We have not ignored any data items. That means rows or columns, everything we are having. And the thing is, we could able to handle that null values with the mean also. OK, with the mean value also, we could able to update that. Now you see there is a little surprise. With the deletion of the column, we could able to see 74.3. With the deletion of the row, we could able to see 80. What is that, friends? 82, 82 point, yeah, 3. 82.3 just by deleting the accuracy, but with mean age imputation, we could able to see 77.9. Generally, guys, compared with these two, we should get the greater accuracy, but due to this data set, one thing is pretty clear. It's not like mean, mode, or median, or the method we are using. It's always 90% of the skewness is due to the data set, friends. So we cannot generalize also. Like even after giving due importance for the corresponding columns and corresponding rows, and I don't want to miss out any kind of the columns or rows, and I want to scope them, and I want to perform some kind of imputation on those particular null values, and even I achieved that. Uh, but sometimes there is a possibility of well, I mean, here the analogy is like this, friends. Maybe in this particular data set, uh, along with the age, we are adding some other fare and all the other things. If you see directly, so obviously, guys, they are negatively contributing. See, sometimes it happens now, like some of the features, maybe giving some burden to the appropriate model, and they are negatively contributing. So just to think through, observe that because intentionally I have taken this case study so as to talk and give you some because we have to be practical as a data scientist community members. We should be very tough on the corresponding entries, right? OK, so with this, you can see that uh, generally it won't happen, guys, but still we are getting this reduction. And coming to the other thing, the fourth method is addition of the appropriate column. Whereas if any null value is there, then I want to add some value. The simple imputing technique. Let me show you that path. So just we are making use of this fourth option, imputing with an additional column. Definitely that is a burden, guys, but still we have to see that because one of the column, the third, third row is null. What we are doing is here we added some value and we have put some narration about that. Okay, we have added some null kind of the thing. And this is very rarely used kind of thing, but still I'm scoping so as to give you the entire concept without any miss out. Now the additional point we can observe here, guys, the simple imputer. Okay, so just let me increase the font. Okay, here simple imputer function from a scalar module to impute the values. Pass the strategy as an argument to the function. It can be either mean, mode, or median. The problem with the previous model is that the model doesn't know whether the values came from the original data or imputed value. Because the problem here is, guys, the most important point is if I'm directly giving mean or mode, definitely model is not aware. Model feels that the entire data set. There is no user involvement in the manipulation of the data. So it feels that. But in this particular case, the model, we are clearly giving the idea. I have done some kind of the manipulation. Actually, this data is not there. I have done something on that data. Okay. So to make sure that the model knows this, we are adding age is missing. Okay. As a additional column, age is missing false. That means age is not missing negatively. And here true means age is missing, of course. And to make sure that the model knows this, we are adding age is missing, the column which will have a true as value. If it is null, then we are using the false. If it is not null, okay, not null. If you are referencing simple, friends, here already null value is there. Then we are informing, we are adding one more column. Just this is the null value. Okay, like that. Otherwise, we are leaving that as a false kind of thing. Now the point is, okay, with respect to that particular thing, how do I implement that? Okay, before going to apply the logic, implementation is simple. Okay, thanks to scikit-learn. Age is missing if age is null. Okay, simply what we are doing is just I'm making use of the imputer strategy. Median value this time we have taken. But one more important thing is we have added age is missing kind of thing. And we are updating that thing like if age is missing means if it is null, that means age is missing, true kind of thing. Now what strategy I'm using, I can use either mean, median. Earlier also we have used the same thing, guys. Here if you observe the specification of the mean value, just fill in here directly we are using the mean value. But with this approach, I explicitly want to mention I am using some sort of mechanism so as to handle the convention. So now data, my imputer, this imputer is involving the updated data frame along with the age is missing column, additional column. And we are strategizing this with the median kind of the things. Now, if you see, as you expected, just it is giving us some sort of the information, whereas we are happy with all our non-null values. Okay, even age is also, though we are explicitly updating, but still we can able to see that as a common thing. Okay, this time age is there and age is missing also there. Total 7 columns I'm having. Okay, age is missing is there and age column, however, all the columns are non-nulls only. 891, all 891 are non-nulls only. Let us see if I try to implement this particular thing and how much accuracy I am going to get. Maybe less accuracy also may be fine, guys, because it is not, we are not going to get conclusion on this method actually. We are going to get conclusion on the data set only. Okay, so this won't change anything, guys, up to the pre-processing. That is the benefit actually. Whatever the steps were doing with respect to the pre-processing, only that kind of at that moment you can play around with the data frame. But whereas once that data processing is over, you can directly make use of the convention like applicability of your model. Okay, na? Simply train test split and then a logistic regression implementation, fitting the model and finding out of the prediction accuracy. So this is also 76.49 around. Okay, somewhat okay. So, but still we are going to strive. So out of these particular thing, our second thing is more actually. Okay, the next, the fourth option has given around 76.49, which is very nearest to the third one. Yeah, though you are using mean of the age, even mean of the age only given the best option compared with the this thing actually. Okay, I mean this thing in the sense we are using the mode and as well as we are trying to specify. I'm using the that imputation on the missing value. Okay, so the last thing and which is very interesting thing to me is guys the fifth option. Uh, like rather than using the technique, we are directly using the uh, regression model so as to handle the missing value imputation. So in case the null values in one column are filled by fitting a regression model using other columns in the data set. And that is in this case, the regression model will contain all the columns except age in X and age in Y. Okay, so here it is pretty uh, similar to our dropping of the column, but let me explain you how it is differ from first method. Then after filling the values in the age column, then we'll use logistic regression to calculate accuracy. See here it is the requirement actually. Okay. Now going back and getting the compiled version, whatever the data I'm having. So just I'm portraying here guys. Just if you observe this notion, um, this time we are directly importing the linear regression kind of thing. Um, so this actually if you observe the working with the regression kind of thing and as well as the decision tree or random forest, um, missing value imputation, variable importance plot finding out are possible through these algorithms also. Now I can say this is one of the such case where we are trying to use our algorithm so as to perform some kind of the activity. Okay, so from sklearn linear model, just we are importing the linear regression and we are creating the reference head. We are printing 5 records. Now test data frame df dot age is null. Okay, we have taken that thing as a test data frame and train data frame. If that is false, then I am taking the train data set. That means true means guys here age is 0, age is not available, that we are placing them in the test data frame. And if age is false, I mean age is not available is false, then age is available, that we are placing in the train data set. Now what we are doing is we are assigning this particular train data set to the Y, which is a bit surprising entry, and train df dot drop. Just what we are doing here, whatever the entries I have collected, we are dropping that age access one friends here in place equal to true. Okay, just I am dropping those kind of the things and then fitting the model. We are just fitting the model. And then in the test data frame, now we are dropping that age and we are predicting that model. Prediction just generally happens on the test only, na test data frame. And finally, we are updating that prediction value to the test data frame of age. So quite different guys here, the point here is whatever the functionality we are using, whatever the aspects we are using, just we are placing that particular point in the observation. If you remember in the target encoding technique, we have used the probability. If you remember in the earlier session, let me show you that. Actually, I have shown you some sort of probabilities. Yes. See here, 65, 57, 59, 57%, 79, like that. Now, in the missing value imputation also, just what we are doing, we are going to perform some sort of analysis with the regression model, and we are trying to give some values there. So now, just the point here is these things are fine. Now, my interest is how do I achieve the accuracy? Okay, because that is the one we are looking for now from all these four methodologies. Now you observe guys here. So I'm taking the whatever the y value I'm having earlier with the help of that imputation, I'm copying in the trained data set. Okay, this is how the methodology proposes. And we are taking this trained DF of survived as y value, a little tricky. And of the null values and all these things remain same. And now we are starting the importing of the logistic regression, creation of the reference and fitting the model, train DF and as well as the y value. Only the training data we are fitting that. Of course, it's common. And logistic regression here we are having many hyperparameters. Okay, C value. If you go back and verify class weight, dual, fit intercept, intercept scaling, L1 and L2 regularization kind of thing. We are using L1 ratio, maximum iterations 100 times, multi-class auto, njobs, and majority of these things, guys, we are keeping as usual. But why I have given this thing is we need to specify some sort of I mean, as we are not following the general convention, explicitly we need to mention these kind of the parameter. Then the model, okay, observes that this guy is using some new technique. That is the fifth technique. I have used linear regression so as to perform some sort of the logic to understand the or to impute the algorithmic imputation. Now here just we are doing y test. SDF survived after the implementation of this thing. And then we are predicting the model. Along with you, I am also so curious, guys, what exactly the outcome of this particular model. Okay, little tricky. And once you try to implement and see the understanding, then you will be getting the catch hold of that. Now you see 83.61, which is definitely. Now let me write all the models performance. Um, Here, whatever we have seen, yes, 74, 82, 77. So 74, 82, 77, and latest we have seen 76 for the fourth model. Definitely compared with all these four models. Okay, of course, deletion of the column, deletion of the row, imputing with mean. This thing, guys, fourth one is what we have seen, mean value, but we are notifying that to the model. This is the fourth one. Now this is the fifth one. Fifth one is nothing but with the regression model, I'm going to perform some kind of the missing value imputation. This is how you can see the understanding and accuracy point of view. Though the approach is little different and I cannot say as a tough, just is a kind of distinct when compared with the other thing. Now let us try to draw some summarizations. So see that this model produces more accuracy than the previous model as we are using specific regression model for filling the missing values. Friends, one simple thing is if you are applying some logic rather than the standard principle, always it gives the better results. Rather than studying as it is, if you apply your brain or if you apply your intelligence, then definitely you will be getting the better results. That's what we observed here. Rather than completely dropping the column or completely dropping the records or else imputing the, of course, out of those five, the second priority can be given to the uh, third methodology, friends. Actually, the majority of our data scientists prefer that missing value imputation in terms of mean, all these kind of the conventions. Okay. And other thing is we can also use KNN for filling the missing values, but sometimes using models for imputation can result in overfitting the data. That is what, friend, because your model is habituated or by then suddenly if you are changing the training data to the test data, then obviously you will be end up with some overfit model. Okay, so because we are clearly giving the entire patterns of the data to the models, and on top of the model again you are going to apply some other model, which definitely leads to the overfit. Just to see that how best you can avoid this particular thing, right? And imputing missing values using the regression model allowed to improve our model compared to the dropping those columns. Generally, that's what we proved here. 83.61 percentage we got due to this handling of the linear regression model so as to perform some sort of missing value inputting. Okay, so this is what how you can specify. Now some sample question I want to give you guys. Maybe here which kind of the question we may get related to this missing values, and I'm giving only a sample kind of thing, guys, not complete data. Um, Suppose if you are handling this kind of the information. So just let me paste here. Yes. In which of the following situations is it preferable to impute missing feature values with their median value over the mean value? Okay, rather than considering the mean value, when can I go with the median value? Okay, so simple. Mean is sensitive to the outliers, guys. Mean sensitive to the outliers, but median is not sensitive to the outliers. Now, even in our company announcements and maybe some of the universities also, they won't say maximum salary, minimum salary or mean salary. They will say the median salary, because for the parents and for the clients also, just it is a more meaningful uh, more meaningful measure compared with the mean and other kind of things. So just think through as a logical question. How do we maintain the convention? So definitely this is a missing value actually, the median over the mean value. When the features are in the Boolean type, no. Type in the sense yes or no, then you can go with the mode actually. Wrong choice. And when the feature contains no outliers, if no outliers means mean is the best thing. This is also no. When the features of the type categorical again we have seen, guys, we cannot use the median or mean kind of thing. We have to go with mode because the repetitions, number of repetitions. Now the fifth option is this is also not possible. Fifth, when the features contain no missing values. If no missing values are there, why we need to impute that meaningless statement? Okay, so the fourth one is when the feature contain a lot of extreme outliers. Outlier itself is extreme. Okay, extreme values. Then it is always preferable to use the median compared with the mean value. So median is good to go if your data is having the outliers, more outliers, extreme outliers compared with the mean. To remember this point, guys. So with this, we can stop here, guys. Just will I'll post these things in the channel. So just you can have a look and come back to me if you're having any doubts. Okay, that's all. Himanshu, any doubts?
Thanks. No,
Yeah.
no, Dr. Pawan. It's really great to know about all the techniques
Yeah,
for
because this fifth one
missing
is
values.
really grabbed my attention, Himanshu, because while preparing the content for
Mhm.
our this thing, fifth one really well. Just to see and try to, whenever you are free, try to implement that aspect, Himanshu. Huh?
Yeah,
See that
sure,
that
for
is
sure.
that is very good, because all four we have seen in the earlier also, but fifth one really caught my attention really. Okay, right.
Yeah,
Thanks
I'll
for
do that.
joining. Okay, and
Thank
hope
you.
you are getting the day-to-day this thing postings and all these things in the channel. So just
Yes,
I'm
yes.
curating because maybe weekly though I am summarizing, but day-to-day I feel
Mhm.
that somewhat I need to scope the day-to-day activities also, and periodically I will be
Yeah.
posting the questions also. Okay, na?
Okay.
So that's all,
Okay.
Himanshu. Thank you for joining. Okay, thank you very much,
Thank you
Deepika.
for the lecture.
Yeah,
Thank you so
yeah.
much.
Okay, bye
Yeah.
bye. Thank you. Yeah.